Great, thank you. Hi everyone, I'm Eric Korman, co-founder, chief science officer at Striveworks. I'll be talking about Valor, which is our platform and model-agnostic evaluation store. Just to give a real quick history of Striveworks, we got our start almost 6 years ago, deploying overseas, embedding with war fighters, really just seeing what problems they had in this space and trying to build solutions to add value wherever we could. Since then, we've been expanding into larger Army, other organizations within the DoD, commercial spaces, and productizing our offerings, but kind of always taking this co-development, boots-on-the-ground approach to it. So what's the problem we're trying to solve? Well, no surprise, there's been just this huge explosion of AI ML. So on this left graphic, we see the number of models over time that have been adding to Hugging Face Hub, which is popular landing point for most open source models. And so today, there's well over 1 million. And then on the right, this is the Linux Foundation's AI and data landscape of just all the tooling available for the whole model development lifecycle, from data management to training, deployment, and so forth. Interestingly enough, there's no T&E section. Hopefully we can help change that. But kind of the punchline to this is it's never been easier, to get access to models and train your own models. And end users are just, have this whole sea of models that they have to wade through. And this is compounded in the DoD because now, there's obviously been a ton of money poured into AI ML. The sea of models is even bigger. And not only do, warfighters have access to the, COTS and open source off-the-shelf models from the previous slide, now there's all these DoD unique models coming from different programs or vendors. And so, we hear directly from our involvement in programs such as NextGen C2 and Desert Sentry that these end users are just overwhelmed by trying to wade through all these models that they have at their fingertips. And so, because of this, it's crucial to have T&E to wade through the sea of models. And we really need new tools and processes to answer just this very fundamental question of, what models perform best on the data that I actually care about. And we know, it's a fact that AI ML can offer incredible benefits, especially in terms of, saving people time and money through automation. We've seen recently in Europe working some GeoInt use cases that takes an analyst one day to go through 30 square kilometers of data. But with AI ML, this takes seconds, right? But obviously, you're not going to get adoptability unless you can trust a model, right? And so that's where T&E comes in, and so it's crucial for the deployment of AI ML. And so, we'll narrow down to kind of 4 key challenges for T&E. So the first is model sensitivity. Second is scalability and discoverability. Third is being able to support a diverse ecosystem with different data modalities, architectures, and so forth. And then the fourth is auditability and reliability, right? You want to be able to trust T&E because T&E is how you trust models. And so Valor is our solution to this. It's our open source evaluation service that makes it easy to measure, explore, rank model performance. Kind of think of it in DoD parlance as a common operating picture for testing and evaluation. So how it addresses each of these challenges. So for model sensitivity, right, where we've seen in the field that a model that maybe was deployed in one region of the world fail spectacularly in another, right? And so you need the capability to really filter down your evaluation data to the pieces that are most operationally relevant and see how your model performs there. We solve scalability and discoverability because Valor is a central service, or can be a central service. So you're not reliant on performance metrics being maintained in a Jupyter notebook that might go away, or worse, and maybe more commonly, as part of a PowerPoint in an Outlook PST file somewhere. It supports a diverse ecosystem. It's agnostic completely of underlying model framework or mechanism that you use to deploy the model. So it doesn't matter, if you're using PyTorch or TensorFlow, whatever. All that matters is that, you can put data in and get a prediction out, and Valor will work with that. And then finally, it's auditable and reliable. Not only does it store metrics, like accuracy and so forth, but it computes it too. So you have a whole lineage of what exactly went into that number that says, your model is 87.7% accurate. And furthermore, the core of Valor is open source. So you can, you actually go in the code, see exactly what created a computation. So real quick overview of the process of Valor. So, end users can interact with it directly via high-level Python client, or other services can interact via REST API calls. So Valor was designed to be, easily integrable with, different model serving frameworks, different data repositories, right? Throughout, everything we do at Striveworks, we definitely take an ecosystem approach. And the basic workflow is that dataset metadata and ground truth annotations get posted to the service. Similarly, model predictions get posted to the service, and then end users or other services can then request evaluations pairing sets of models against sets of data sets together with fairly arbitrary filters that spell out exactly what the data is that you want to evaluate on. These evaluation metrics are then saved and queryable, so they're discoverable. Again, anyone with access to the system can see what's there. The components that go into evaluation are also saved in the service so that subsequent evaluations can happen very, very rapidly. And so, I'll jump into a live demo, and we'll show 3 different ways of using Valor. The first will be integrating to an MLOps platform. The second will be more of a high-code power user who's interacting with Valor in a Jupyter notebook. And then the third is going to be Valor integrating to an application layer, namely an LLM-RAG workflow, and giving kind of real-time evaluation metrics back. Okay, so this is Valor integrated into an MLOps platform. In this case, the MLOps platform is called Chariot. It's actually our Striveworks' core offering, but Valor, as I said, is meant to be integrable, pretty generically. And this particular use case I'll go through is of an ATR use case. So imagine an analyst, is trying to detect a specific object of interest in a specific region of the world. At their disposal are a bunch of different models. And so here, we have 3 models trained on EO imagery. We also have 3 models deployed on SAR imagery, right? And we want to see, well, for the region I care about, for the object class I care about, what model is most performant? Which one should I actually use and trust the results of? So, you can use Valor to calculate, the metrics overall. So this is ATR, it's object detection. Standard metrics there are, average precision metrics here. We see, for this label class, say naval vessel is what we're interested in. We can get this ranking of models based on, say, average precision, which again is kind of like the standard metric used in object detection. And so in this case, we see that this model M1 is most performant overall. And so this is this, faster RCM model trained on EO imagery. But of course, as I was saying, models can be not robust and their performance can really vary on different subsets of the data. If I'm interested in a particular region of the world, I want to be able to just, draw a polygon on a map and see, well, what model performs best there. And so, in real time, Valor is doing the filtering and recomputing metrics on this most operationally relevant data. And now we actually get a different ranking of models, where this other model down here, which is actually operating on SAR data, is more effective for the use case I care about. Valor will also, besides these standard metrics, it'll also provide examples. We can see for the different models, if it hallucinated something, that is, it predicted something that wasn't there at all, if it missed a prediction, if it misclassified something, so it got the area right, but it said it was, a bus, but it was really, a sedan, and also examples of accurate predictions for the various models. So that was a low-code usage of Valor. Here we'll show a high-code usage of a programmer operating in a Jupyter notebook. As I mentioned before, Valor has this high-level Python client that enables users to interact with the service programmatically. And so first step, I'll just connect to the service. Again, even though I'm executing these things in these notebooks, all the communication is going to the central service. So if this kernel dies or this notebook gets destroyed, everything I've done is still existing in Valor. It's discoverable, it's accessible to other end users of the system. And so this first example, we'll just kind of browse, use a Valor client to browse what's already been put into Valor. And maybe I'm interested in this, wildfire prediction use case. And so I can grab the corresponding data and model for it, and now quickly kind of just browse through, see what the data looks like. In this case, we have this metadata associated to the underlying data, so things like day, land area, the sensor that it was collected from, either drone or satellite. And so, maybe for some reason I'm interested in seeing how well this model performs in the summer and for small land areas and for data that came from a drone. And so Valor supports, again, this very robust filtering system where I'm saying, okay, I want to evaluate, but just give me the data, where the day is between, June and September. So, summer months, land area less than this user defined value 500, and the data source, a drone. And so I can get this, high fidelity evaluation on that specific data. Or maybe I'm interested to see the trends in, well, how does accuracy vary as a function of land area? And so I can write this kind of simple for loop that's iterating between different bounds of area, and use standard tools like matplotlib to get this plot. I see this nice trend that overall seems like bigger land area corresponds to more accurate. That's very useful information to know, right? Now I can have more reason to trust my model if I'm evaluating against large land area versus smaller. Similarly, maybe I'm interested in what data source the model is more accurate on, right? So I can do two evaluations, one where I'm filtering out data coming from the drone, the other from a satellite, and see, okay, this model performs better on data coming from a drone. Maybe I want to invest more of my money in collecting data from a drone versus satellite. Or maybe if I have more satellite, it's easier to get satellite data, maybe I need to retrain more on satellite data. And so, this example, we were interacting with data that already existed in Valor. Of course, you also want to be able to create things programmatically. And so in the second example, show what it looks like for a user programmatically to add data sets and models to Valor. In this case, I'll just go through this toy example with scikit-learn, right, training a logistic regression model on a toy data set from scikit-learn. This is the model training, and then Valor has these high-level data set model objects I can create associate to that model, and then this add ground truth, add predictions. That's adding the ground truth and predictions of that model and data set to the backend service, and then I can go ahead and evaluate and get standard classification metrics back. Again, these metrics are going to be stored in that central service, discoverable, queryable, obtainable by anyone with access to the system. Okay, so now this final use case is Valor embedded in the application layer. So this is a simple LLM, retrieval augmented generation kind of chat interface. Again, the special sauce here isn't like that we can deploy an LLM-RAG pipeline, but it's that Valor is running alongside it to evaluate the pipeline. And so here, I uploaded some fake ConOps. And so, you can imagine an analyst wanting to ask questions. What operation took place in July 2024? Right, the retrieval augmented generation system is going to spit back an answer. Desert strike occurred there, and then per query, Valor is computing metrics. Right, LLM-RAGs are real. They're very useful. Right, but we know they can just flat out make things up. Right. We also know that the mechanism you use for the retriever can vary depending on the data source, right? The system is very dependent on that embedding model. And so you want some metrics to quantitatively let you know how your pipeline's doing. We support a bunch of metrics in this case, but here, we've just plugged in two. One is context relevance, so that's how relevant is the retriever part able to get data to answer the question. The second is hallucination. From 0 to 1 of how much this model hallucinated. In this case, it's saying there was no hallucination, which is good. And so, it's nice to get back this, kind of immediate information gauging the performance of the model, but you also want to be able to see how a model is doing in aggregate. And so, Valor is storing over time these values. And here we're applying just a histogram of those values. So that helps to give an aggregate performance measure of your model. It's also helpful for the user to see, okay, like how do I put these scores in context, right? How do they compare to what's expected, right? And here, data scientists will look at this and say, okay, context relevance is pretty low. Maybe I need a better embedding model for this RAG pipeline. Hallucination is pretty good. I'm happy with that. I'm good with the LLM aspect of this pipeline. That sort of analysis is what this enables. Sorry about that. Okay, so what do we support right now? We support classification for any data modality. In computer vision, we support object detection, instance segmentation, semantic segmentation with the standard metrics. NLP, we support text generation and RAG metrics. So like kind of the more modern LLM-driven ones like hallucination score, context relevance, but also classical ones like sentence BLEU scores. When we compare Valor to other offerings, there's a few key differentiators. So, one is lots of offerings in the T&E space only support, say, NLP or only computer vision. Valor supports both as well as other data modalities. There's no human in the loop, especially for generation tasks like LLM. Some offerings, just set up this battleground where they're comparing outputs using people. To do the comparison. That's obviously not scalable, no pun intended, and so you really want it to be as automated as possible. And then another value add for Valor is that's open source, right? That helps with the trustworthiness, auditability of the system. And then finally, it's integrable with an end-to-end MLOps platform already, namely Chariot, and that platform has been deployed both in the commercial space and all aisles basically within the DoD. We're pitching a 18-month phase 2 SIBR. The major things we want to do are work on that UI. So the UI I showed is real, but it's something that we've just worked on the past month or two. So we really want to expand that out, get some more visualizations. That example visualization we saw was like just pushed to prod yesterday. So we still want to continue building on that. And then the key thing is integration, right? Like T&E is useless without rich data sources to evaluate against and a rich set of models. And so we envision a lot of integration with the model and data set repositories that Linchpin has, as well as the other winners of xTech, right? We see lots of complementary offerings, which is really great, and we'd be excited to pair with them. The biggest risks we see are the risks that we've seen throughout our life at Striveworks, which is network access, ATO, compute availability on these on high side and other networks. These are all risks we've seen and we've overcome. For example, with our deployment on Chariot, which currently sits on aisle 7 and is in active use. Talk a little bit about public opportunities. So, like I mentioned, we already have Chariot deployed in a lot across the aisles and various DoD organizations using it. And we see again a huge market here just in 2024. Estimated $2 billion TAM in T&E alone, and this is only going to grow as adaptability of AI/ML increases. In commercial opportunities, so we've already commercialized our dual-use technology, especially previously with Chariot, and we have a lot of paths to bring Valor to the private sector, both direct sales and joint ventures. Again, lots of our approaches in both sectors are an ecosystem, partner approach. Particular, industries that we've started making some inroads in are things like healthcare, manufacturing, automotive industry, financial services. Have a lot of commercial channel sales to get our platform offerings out there. And then here, like Arete, who's part of this convention, have a little vignette of our work that we're doing actively with them. Prospector is an interesting commercial case. That's a commercial mining company, and so we see some parallels there, right? That's like very geo-int, but in the commercial space, and we're kind of excited about there. Overall, we see in the commercial space this year, $16 billion AI/ML T&E TAM.
Like that.
Like I mentioned a few times, crucial to AI/ML is really an ecosystem approach, right? You need to be able to support the diverse data sources that are out there. platform integration so that your service is actually reaching end users, and ability to deploy in diverse environments. Again, we've been on TS networks, we've been on commercial spaces with Kloss. You can see at our booth or theirs, we have a ruggedized box that Chariot has been installed on. So really diverse deployment settings. Thank you.
All right, so we'll now move to the 10-minute judge Q&A. Judges, whenever you're ready.
Right. You said you can customize the metrics, right? With the UI that you're putting together, within that you can tell it what to give you back.
Yeah. So within that you can specify tons of different filters. For example,
precision was the recall.
Exactly. Yeah, those metrics. Also, something we're working on is completely custom metrics, especially on the NLP side where things are a little fuzzier. And you might want to change the prompt. We support that.
Yeah. And then that class box, is that the void?
Yeah, I believe so. Yeah.
It's a good part.
So for the data and models that you're posting in there, it's highly dependent on the quality of the metadata. Have you seen issues or for how you're generating the metadata to be sufficient to be then able to support your analysis?
Yeah, that's a really good question. I mean, I will say obviously the baseline, standard T&E offerings don't take any metadata in mind, right? You just have your, the GeoInt case, like this image, and you have, the ground truth labels. But yeah, I mean, actually, we see the opposite problem of being almost, being hounded by metadata. When we work with our geospatial data providers, I mean, there's all this metadata, distance from the sensor, look angle, all this stuff. It's so structured and it's not being, it kills me, as a data scientist that all this information isn't being used, right? In testing, evaluation, or model training. But yeah, so we haven't run into a lack of. Yeah.
Do you have some initial cost metrics? It's this hard. It takes 2 weeks to run this, even at a small scale.
Yeah, that's a good question. It has a very small footprint, partly because of this guy. This is Adam Salo, VP of Product. He's very on the grounds. Our IL7 instance, for example, is very resource constrained, especially because it's hosting this platform that's deploying models, right? And those need a lot of compute resources. So our engineering team, hounded by Adam to make this as resource light as possible. So I think, for example, on the production cluster I was demoing on, it's maybe 4 gigabytes of RAM and 2 virtual CPUs or something like that. That's the order. So very light. That's been a huge engineering effort for us.
So what you have today, a lot of what you talked about, things you already have metrics that Valor is able to determine about the different data models.
Yeah.
What are you looking to do? You talked a little bit about what are you looking to do with this that we're wanting to advance the ability forward. There's a couple of different modalities, things like that.
Yeah, that's exactly right. So I mean, a few things in terms of data modalities. We really want to integrate with the data offerings there are, and so it's going to be a bit shaped by our access and linchpin and seeing what's out there. But independent of that, there's a ton we want to do. For example, full motion video is very common, right? And so there you get not into these object detection ATR metrics are per frame, but what about multi-object tracking metrics? So that's one that we started thinking about. Another thing is time series data. Or even, predicting, the next value or regression metrics. Those are simple things that we can add. And so there's lots of use cases there. Audio, embedding models is another thing that would be good to evaluate, especially with the use of RAG pipelines, where that embedding model that retrieves relevant documents is crucial. We want to be able to evaluate those. So we don't have support yet for embedding models. That'll be a little more work than some of these other data modalities. But that's where our thinking is now, independent of linchpin, but we're definitely eager to get on the ground and see what the key use cases are there.
Right. Okay.
Yeah. If I had if Is Chariot going to come with this baked into it or no?
That's a good question. Our VP of product, Adam.
Yes, the first demo you saw, that was Chariot, and that's this core operating Chariot.
Yeah.
But we can also break it apart.
Exactly. Yeah.
open source, right?
Yeah.
The Valor library is open source.
Yeah. That's exactly right.
Yeah. You want to be rabbits?
So do you have this, you said this is, Valor's approved for IL-6 and stuff. Is this actually deployed on any, like, Army system right now, or maybe like an Air Force platform one?
So do you want to talk about where it's deployed? Sorry.
Yeah, so right now, to your point of is it deployed with Chariot, it is deployed with Chariot. It's on the NGA's Advanced Analytics platform, so Chariot has a swap approval to be deployed there, so therefore it's JWIX facing there as well. And then it's also been part of the next-gen C2 deployments as well. That's mainly on IL-5 right now, and Chariot is going through through Palantir's FedStart program right now to get FedRAMP approved, and then have that as a certification as well.
Right, so a lot of that is like facing like the JTIC side and like that tactical. What about the other side of the house of like the development, the R&D side? Do you have any? Has it been deployed?
Oh, like into like any R&D spaces?
For example, like let's say I want to select a model that I'm going to use for object detection, design for front-end record.
Right.
I might want to use this to actually evaluate all those different models. Has that been something that you guys have explored?
Yeah, so it's something we're exploring right now. So we're talking to like C5 ISR, like the Atlas program, and some of the computer vision programs there, where they're still, building, those systems, and so we're working through that as well.
Okay, cool. It's nice.